How does energy conservation apply in thermodynamics? Have you ever wondered how energy behaves in our world? The concept of energy conservation is a fundamental idea in thermodynamics that helps us understand this behavior. So, how does energy conservation apply in thermodynamics? Let's break it down. Energy conservation in thermodynamics is primarily explained by the first law of thermodynamics. This law states that energy cannot be created or destroyed. Instead, it can only change forms or be transferred from one system to another. In any thermodynamic system, the total energy remains constant over time, even if it transforms into different types such as heat or work. To grasp this better, let's look at some basic concepts. Thermodynamics is the study of how energy moves and changes within physical systems. It often focuses on heat and work. The first law of thermodynamics gives us a way to quantify these changes. It relates the change in a system's internal energy to the heat added to the system and the work done by the system on its surroundings. Mathematically, we can express this as change in internal energy equals heat added to the system minus work done by the system. This means if you add heat to a system, its internal energy increases unless the system does work on the environment, which would reduce its internal energy. Now, what is internal energy? It refers to the total energy stored inside a system, including the kinetic and potential energies of its molecules. Heat is the energy transferred due to a temperature difference, while work is the energy transferred when a force moves something. The principle of energy conservation ensures that all energy changes in a system can be tracked by monitoring heat and work exchanges. For instance, when a gas expands in a piston, it does work on the piston. This action reduces its internal energy unless heat is supplied to balance the energy loss. From a practical standpoint, this principle is essential for engineers and scientists. They use it to analyze engines, refrigerators, and other devices. By balancing energy inputs and outputs, they can predict how these systems will behave. It also means that no energy is lost. It merely changes form. This understanding is vital for designing efficient energy systems. In essence, energy conservation in thermodynamics means that the total energy within a closed system remains constant. Any change in internal energy results from heat added or work done. This foundational idea connects various physical processes with energy accounting, making thermodynamics a practical tool for understanding energy transformations in both everyday life and industrial applications.